Alright, so let's look at a review for test 1. First thing is making sure that you know when it is. Our test 1 is this upcoming Monday, and in terms of the sections that it's going to cover, it'll cover essentially everything that we'll talk about with classical geometry. So you should expect to see things that are proofs, but you should also expect to things that are correct formal classical constructions, as well as some extra questions to talk about what I consider theory questions dealing with things like terms and how to interpret various stuff. Now, in terms of how this particular study guide is organized, the first page here is going to talk about the format of the questions and what to see. The next page is going to be a list of all the definitions I expect you guys to know, just to make sure you can read the questions appropriately and know what they're asking. And then the next 2 pages will be some more directed guidance on what things you should look at to prepare for construction questions and what things to look at so that you can prepare for proof questions. But let's start off with what type of questions you should expect to see. Now, these notations are specifically for if the test is in person. So I'm going to give you both what I think of in terms of like an in-person scenario as well as a online scenario. Okay. So if this test was an in-person question, it would typically be 5 pages, and the first page would be dedicated to various questions to talk about: do you recognize what's going on? If you have this proposition, what do you need to use it? What would you then get after you used it? Those type of things that we've also talked about in class. Now, in an online setting, those questions wouldn't be on a single page because, well, it's different. I'd break up those questions into their own individual questions that you would see. So maybe typically for an online version, I would typically have about somewhere between 2 to 4 of these type of questions. Normally it's more in the range of 2 to 3 of these type of questions, where maybe one of them is dealing something with symbols and recognizing what's going on in whatever your geometric scenario is, and maybe the other one is more dealing with a definition, terms, or using a proposition. Okay, so notice for all of these guys here, it's talking about definitions. When I say named theorems, these are referring to guys like side, angle, side. So our triangle congruence theorems, I guess I didn't need to write that parenthesis there. Side, 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 angle, angle, side, angle, and right angle, side, side. And those are the big named theorems that we have, okay? I will also expect that if you're given some proposition, maybe it's specifically referring to something like one of these named theorems, or maybe it's referring to some other proposition, and then I would give you, what the statement of that proposition actually is. In either case, maybe you would then be asked to explain when you would use this, what would be the situation that you'd need to look for, and then how it would be beneficial to you. And maybe you'd be asked a similar type thing with respect to a definition. Okay, so those would be some of the key things with these theory questions. And let me add in here another thing that I'll often do, being able to recognize and use the correct symbols and notation. So when you're studying for this test, if you look at the some of the sample questions that I've provided in the practice test, as well as if you go back and look at some of our Canvas quizzes, you'll notice that some of those Canvas quizzes, as well as in the practice test itself, it'll have a couple of questions. They're just straight up of, can you correctly use the right symbols, or which of these options, in I think one of them is a multiple choice question, which of these options is the correct usage of this symbol, okay? And that would be one of those hopefully really straightforward questions, okay? Now, that's not the main focus of this test. The main focus of this test is looking at construction questions and looking at proof questions. So first of all, if we look at construction questions, with construction questions, I typically give normally about 2 to 3 construction questions. The one construction question here where I put it on the list is potentially what happens if I rearrange these construction questions, and maybe one of them does something like gives you a potential construction that fakes someone me, put together, and you're doing an evaluation of, is this a proper construction? Think similar to the question that you had from the homework 2 wrapper, where you were given a construction. Well, you actually were given 3 of them, and you were asked to evaluate, was this a good construction, what was missing, what was not missing, those type of ideas. If you don't have one of those questions, you're probably going to have closer to 2 proper construction questions. And in terms of creating these construction questions, here's how they go. If it's an in-person test, I would just give you the statement of the question, and then you write everything on a blank piece of paper. In an online version of a construction question, I would still give you the statement of what it is that you would see in Canvas. Then you would have a text box where you write down all of your construction steps, and then you would have to upload your picture of your construction. Now, why is that? Because a construction entails 3, or really if you prefer 4 main parts. One of the parts is you need to make sure that you state what you're actually given in the construction. In other words, are you given your starting point is your straight line? Okay. The other thing that you need to make sure that you write down is the steps that you used. This is specifically what you used. I don't care if you cite these steps or not. You're just writing down and giving me a log of what you did. Okay. Proper construction steps are written as commands. So it's not a sentence of, hey, at this point I drew this line and I used my straight edge. It's draw line segment AB. Okay? So short, they're sweet. They're not tons and tons of essays. These are just bullet pointed directions. Okay? You also need to make sure you state your claim. The claim is what you think the result is. So for example, I think our first construction question that we did in this class was we constructed an equilateral triangle. Your claim in that point would be something like triangle ABC is an equilateral triangle. If you use different point labels on your points, maybe you'd say something like triangle PDQ is my equilateral triangle. And this is the part of the question, typically only worth like 1 point, but this is the main point of the question where I know that you got to the desired answer. Now, the other thing that you have to have for your construction is you actually have to have the picture. Okay? And this is the part that if we're in a Canvas setting, you will have to upload this picture. Now, it is currently set up, since you'll have an online test, where you have a second assignment that's outside of the test where you'll upload your construction picture. So don't forget to upload your construction picture. Key things you have to know with this construction picture is you do need to actually use only your straight edge. And please remember that a straight edge, while you may use a ruler that has all the little notch marks on it, as in use it where to draw the straight line, you can't use it to measure things. You also need to make sure that you're only using a compass. And remember, a compass is the one that has the 2 pointy ends that kind of look like feet. Okay? You're not allowed to use a protractor or a ruler to create the construction. Now, totally fine if you use the protractor and ruler to check to see if your work is correct, and if it's not, you can redraw the picture type thing. But those are the only 2 tools, plus your pencil, that you're allowed to use to draw these pictures. If you're using things like computer-generated graphics or freehanding it, you will get no points for the picture part. In a standard construction question, if this was like a homework set where I'd grade these out of 8 points, you're typically looking at your givens and your claim and your steps all together 3 points, and you're typically looking at your picture is around 5 points. That is only true if this is an 8-point question. With respect to test, these guys are typically graded between 10 and 20 points, and in that case, the percentages are a little bit different. If I do a 20-point question, typically the picture is worth 15 points, and the steps, claim, and givens are all worth 5 points. So notice here the main goal is getting to that picture correctly drawn with your straight edge and compass, and then did you actually get the picture you cared about? Okay, so key things to remember. You want to make sure that when you're drawing this thing, you have a fully formal and correct Euclidean construction. The formal Euclidean construction refers to only using the straight edge and compass. Now, how do I tell if you actually have created your picture using a straight edge and compass, it's super duper easy to see because there's lots of construction marks along the way. So if you go in and erase your construction marks, you won't have the evidence that you actually used your straight edge and compass, so make sure you don't erase those construction marks. The other thing that I look for is actual accuracy. So if you were asked to construct an equilateral triangle, I'll check, did you actually get an equilateral triangle? Okay. And this would be where I would actually take like a compass, set it to the length of one of your sides, and then check to make sure that's the same for all of your sides in an equilateral triangle. Now, in terms of dealing with the steps, make sure you list them all out. Please don't forget to label all of your individual points that you have that you're then going to reference. So for example, if you say, hey, draw in line segment AB, and there's no point A and B in your picture, I can't really tell what you're doing. The stating your result, that's the same thing as stating your claim. And key thing here is you do not need to prove one of these construction questions unless it's a second follow-up to the construction question, which it is unlikely that I would give to you in an online form. In a in-person form, I have done this before where part 1 is you draw the construction, part 2 is then you prove that your construction is accurate, but in an online form, I would break those into 2 separate questions, and if you were asked to prove a construction question, I would give you what the construction was at the top, and then you'd prove it at the bottom. Okay. So that's the deal with these formal classical constructions. Now, the second big topic that we'll have, or I guess technically here third in terms of what we've talked about so far, is dealing with proof questions. So with proof questions, you could potentially have somewhere between 1 and 3 proof questions. Normally I do about 2 of them. So here are the things that you can expect to see. I am not expecting you to have all of our facts memorized, so a list of the propositions from Euclid's Elements will be provided. If you go and check out the practice test, what you'll see is a sort of demo of a very short list of how I would provide those propositions to you. Okay, so I would give you what the name of the proposition is, which is all you need to cite in your work when you're doing your proof, and then after the name I would give you exactly what the statement of the proposition is. But fair warning, I won't copy it exactly from Euclid's Elements. I'll put it in modern language, so hopefully that makes it easier for you guys to read. Okay, now things that you will need to make sure that you can do. You need to make sure that you can actually use these propositions. So if you're told, hey, you've got proposition whatever, maybe 5, and I write it out, you have to make sure that you're savvy enough that you know how and when you'd be able to use that proposition. Okay. The other thing is I am expecting you to be able to recognize and deal with correct symbols and notation. So if you see some sort of symbol being used, you know what it means. Make sure you're good with that. And same deal, I am expecting that you know some basic definitions. Okay. Now, when you're writing your proof, don't forget to cite each thing that you've used, each step. If this was an in-person, face-to-face, on-paper test, you would have the statement of whatever it is you were trying to prove at the top of the page, and then a blank piece of paper that you would write your own little T-chart in, and you'd write each step in. In an online format, we don't have exactly that same thing. What I will do for proof for these test ones is you'll see a T-chart. You'll actually visibly be able to see the T-chart. And then at each step, you'll be able to fill in what should go in each of those steps. Okay? So notice what that does. That automatically gives you blocks of where you should be citing your work. Now, be careful in terms of citing your work. In order for this to be taken correctly in Canvas, you will need to use the proper notations and how to cite things. So for example, if you wanted to cite, say, something like Proposition 5 from Euclid's first book, you would need to type it in exactly as bracket capital letter I, comma, 5, close bracket, and that's what Canvas will then take in an online format. Okay. If all you write is I, comma, 5, if all you write is 5, if you use parentheses instead of brackets, Canvas will not count it as correct. You need to actually do the correct citation, the correct symbols. Now, good news is I'm providing you a list of all of your propositions, postulates, common notions, etc. So what you can do is the names that I give you on that list, you can literally just highlight it, copy and paste from that list you're given, and drop it immediately into the appropriate line where you need to cite things. Okay. Now, just as a heads up, while I'm not going to give you everything we've talked about in Euclid's Elements, I will give you more propositions than what you will actually use. Part of this is that sometimes there's more than one way to write a proof. Some of it is just to give you options, so I'm not giving away the answer. So there will be much less than what you would see if I just gave you Euclid's Elements, the entire book. But no, if you don't use everything on that list, don't freak out. You're not expected to. And watch out if the thing that you're proving is actually something from Euclid's Elements. There may be limitations or restrictions on what proposition you are allowed to use. Sometimes that will affect the proofs that I give to you guys, and sometimes it won't. If that's something that would affect it, I will put a reminder in the actual question itself that says, reminder, don't use any proposition after, and it'll give you a number. Or it'll tell you, hey, this is proposition such and such from Euclid, and it'll give you the number of what the proposition is. Okay. Do make sure that you use a T-chart when you're writing these things up, and if you need a picture as a reference, feel free to draw one. Note in an online version and actually on a paper version of these tests as well. Paper version, I won't draw the T-chart. Online version, I typically do. But for the picture, I will typically give you the baseline picture for anything you're asked to prove in either of these two versions. Although if you want to add lines to it, definitely do so. And for an online version, if you've adjusted the picture and renamed it and done some scratch work on your picture, do please upload that to the scratch work assignment. Okay. Now, sample questions, if you want to look over things that we've done. Anything we've worked in class, including the activities, which the solutions to the activities should either all be posted or should be have their solutions posted soon. Examples we worked in class, examples, extra examples out of the textbook, and this would also cover topics from homework sets 1 through 5. Homework 5 will be due after the test. Please note we do right now have enough information for you guys to complete homework 5. So those are also potentially questions that are similar to something that you could see on the actual test itself. Okay. So now on to page 2. So page 2 talks about definitions. So these are the type of definitions, and that also includes some notations and propositions as well. These are the main definitions that I'm expecting that you guys already know. As you read through this, please note that this list is almost exactly the same as that first definitions assignment that you guys had, that Euclid's definition assignments. So notice, I'm expecting that you know what a point is. I'm expecting that you know what a line is. Technically speaking, surface and plane surface we won't have for the test. I am expecting that you'd know so what parallel lines are, what transversals are. So parallel lines, transversals. I am expecting that you know what angles are. Rectilineal angle just means it's a normal angle that we think of. So definitions of right angles versus perpendicular lines in my little hand-drawn scratch work there. Obtuse versus acute. Angles, vertical angles, which look like that. Supplementary angles, which look like those guys that form 180 degrees, and complementary angles, these are the ones that form 90 degrees. I'm also expecting that you know what alternate interior angles are, what alternate exterior angles are, and what corresponding angles are. Corresponding are like that. And if you need the ones like we've talked about with the Euclid's fifth postulate, they are ones that would be, you have to describe them a little more. They would be ones that would be interior angles on the same side. So that would be like these guys, okay, which are not alternate interior, alternate exterior, or corresponding. They're just different. Okay. I am expecting that you know what a figure is. Boundary. A figure is simply some sort of geometric object, typically a polygon or polygon shape, and the boundary is simply like going around the edge, like the perimeter, if you will. Okay. In terms of circles, I am expecting that you guys know basic pieces and components of circles. So, for example, making sure that you know the center of the circle, radius of the circle, diameter, chord, tangent line, relationship here. We've got what if you have a circle and you have a radius. The line tangent to the circle at that radius point always has a right angle. And the other thing that we had with respect to chords, so here's a chord and there's a center. If you bisect your chord, any chord, it will always yield a line that passes through the center. So those are the two main relationships that you need to worry about when I talk about relationships between radii, chords, and tangents. This is also on your handout for book 3 that we had previously. I'm expecting that you know what a semicircle is. If you talk about an angle subtending an arc, this is this guy. So the arc is here, and the angle subtending the arc, this is the angle formed where the two rays of the arc intersect your circle at those ends of where the arc is. Okay. And inscribe versus circumscribe. Note here, order does matter. So if you have a polygon and it's inside of a circle, I'm going to be lazy and do a triangle here. That is, the polygon is inscribed in the circle, or the circle is circumscribed about the polygon. It's the same thing. But here, the key things, notice the points of the polygon are on the circle. Now, suppose we had this other way, and I definitely should have drawn it the other order, where the circle's on the inside. Notice here in this other orientation, each of the sides of the polygon are tangent to the circle. They touch the circle in exactly one spot. And in this time, we're told that the triangle circumscribes the circle, or the circle is inscribed in the triangle. Okay. Now, rectilineal figures. This is exactly the same thing. Well, it's not exactly, but it's almost exactly the same thing as just talking about a polygon. So polygon. Polygons have two words for them. They can either be called polygons or n-gons. N-gon, n refers to the number of sides, so it's a more lazy way of saying polygon. And then we've got the terms that we've talked about before. Equilateral, all the sides are the same length or are congruent. Equiangular, all the angles are the same degrees or congruent. And regular means you're both of the previous two. Okay? And then in terms of here, you can actually calculate the degrees of the interior angles of your circle. So this would look like this, based on the number of sides of your polygon. So suppose we have this polygon, and strategically here it would have to be a regular polygon. Pretend that's a regular polygon. Sides of regular polygon. Notice what you would do here. You would just take 360, divide by the number of sides, and bam, you're able to find that interior angle. Okay. Now, next thing, and this is something that we've dealt with tons, is dealing with triangles. I'm expecting you know the definition of equilateral, isosceles, or, and typo here, this should say scalene. And the key thing here is equilateral. All the sides are congruent. Isosceles, in our context, both how Euclid does it and for our class, isosceles exactly 2 of the sides are congruent, and here with scalenes, none of the sides are congruent. So that deals with sides. Other types of triangles are right triangle, obtuse triangle, and acute triangle, and that depends on the angles. Right triangle, exactly 1 right angle. Obtuse, exactly 1 obtuse angle. In both of those two situations, both the other 2 angles are, oops, I did it the wrong way. In both of those 2 situations, the other 2 angles in the triangle are going to be acute, and for acute triangles, all 3 angles are acute angles, or less than 90 degrees. And last type of triangle that we talk about is a golden triangle. Okay. Quadrilaterals, we talked about squares, rectangles, rhombuses, parallelograms, and trapezoids were the 5 big quadrilaterals that we talked about. There are other types of quadrilaterals, but these are the main 5. Make sure you know their definitions. So for example, the definition of a rectangle is just 4 right angles. Definition of a square is it's got to be a rectangle plus all the sides are congruent to each other. For a rhombus, the only thing you need is all sides are congruent. For a parallelogram, opposite sides are parallel to each other. And for a trapezoid, you have one pair of opposite sides are parallel to each other, and it doesn't matter what happens with anything else. Okay? So those are our guys with quadrilaterals. And notice we can apply previous things that we know with respect to rectilineal figures to both triangles and quadrilaterals, because this is general for all polygons, and these are specific polygons of 3 sides or 4 sides. And then lastly, notation and propositions. Propositions, again, these are the named propositions we talked about earlier. I'm expecting you guys to be able to deal with them just fine. And in terms of notation, the big thing to deal with notation, make sure you know the difference between equals versus congruent. And in InPerson, where you handwrite everything, I do expect you to use the correct symbol. If you're typing things, unless you can use math mode, you can't actually type a congruent symbol inside of a typing scenario. So in those cases, I'll be a little bit more lax in terms of whether you've used the correct symbol or not, if you have to type it. But note, if you have access to math mode, and in Canvas, that's the menu button that looks like a square root X, you will be able to actually pick out this congruent symbol. In that case, I would assume or expect you to use the correct symbol. Now, in terms of these other ones, A here would just represent a point, angle of A, the degrees of angle A when it's ambiguous, or the true proper name. This one here is line segment AB, ray AB, and triangle AB, and if you have other polygons, they don't have symbols out front. Okay. All right. Second to last page, this one talks about different types of constructions, and I've categorized these in a couple different ways. So the first part is really more construction steps. So for example, make sure you can actually draw a straight line correctly, straight line, so that's using a compass. Make sure you can draw a circle correct. So this is straight edge, this one's with a compass. Make sure you're comfortable copying a line segment, copying an angle, bisecting either an angle or a line. Make sure you're comfortable drawing a perpendicular line. Make sure you're comfortable drawing a line that's parallel given to another line. Okay, those are your main construction techniques. Now, basic and related construction techniques, make sure you're comfortable drawing an equilateral triangle, and make sure you can construct with your actual compass and straight edge, not with your protractor, an angle of some given degree. Okay, now I won't give you any old angle because it's not possible with any type of angle, but these would be some of the main ones. Make sure you can get a 90-degree angle, 45-degree angle, 30, 60, and some related type angle. Okay, so those are your main construction techniques or steps in your other constructions. Now, what I consider relatively straightforward constructions, and many of these are examples taken from what we've either done in class or on prior homework sets. For example, exercise 214 from your textbook says, all right, you've got some line segment. How would you subdivide it into n congruent line segments? So not just bisect it, but maybe you trisect it, or maybe you divided it into 5 pieces. How would you do this? One of your previous homework sets had a question that said, if you're given the circle, just the outside of the circle, how would you do a construction and actually find that center? So that would also be something that you want to make sure to do. Exercise 2.11, this is the one where you were given a circle, you were given a line segment to the side, you were not given a circle, let me back up. You were given a line segment, and you were told, hey, I need to construct a circle. I believe you were also given this guy here. You need to construct a circle where this guy right here is exactly congruent to your given line segment. Okay. So this one's not 100% straightforward, but it does take into consideration some of the things that you'd want to worry about with respect to the relationship between chords and center of your circle. Okay. This one here says if you were given a circle and a point outside the circle, can you draw in a line that's tangent to your circle through the point? And last one right here, if you're given 2 lines, maybe something like this, can you draw in a circle that's tangent to both of them? Notice all of these are things that you've either had previously on one of your homework questions or something that we've done in class. So these I would consider, they're not one-step questions, but they're relatively straightforward questions where you're just using a property that we already know about. Okay. Now, there's also what I consider intermediate constructions, and just as a note here, former students of mine have definitely told me that they think what I tag as intermediate constructions, they think are actually easier to remember than some of what I would consider the more straightforward constructions. Now, I don't know that I actually believe that the straightforward ones are harder than the intermediate ones. I suspect it's more they studied more about some of the techniques with the intermediate guys as opposed to what I consider the more straightforward constructions. But just as a heads up, people typically do relatively well with these guys, just as a note. Okay. So intermediate constructions, notice here this is talking about inscribing and circumscribing your polygons either in or around a circle. In terms of the type of polygons you could see, realistically you're looking at polygons of either triangles, 3 sides, 4 sides, so things like squares or rectangles of doing this. You might be asked for polygons of more sides, like a hexagon, or maybe a special type of pentagon, but realistically it's not going to be a polygon with a lot of sides, realistically here. Okay. This one here is one I believe we did in homework. It says, given some line segment, given an angle, go ahead and draw in the parallelogram and or rhombus and or rectangle that meets those criteria. Notice with a rectangle, the angle would have to be a right angle, so I wouldn't really give you the rectangle in that case. But with the parallelogram and the rhombus, I would need to give you what the angle is. And when I say give you, it could just be where I tell you what the degrees are, and you first have to construct an angle that has that specified degrees, not using your protractor, and then second, construct the quadrilateral with the appropriate degree inside. Okay. Now, advanced constructions. Advanced constructions, the ones that I would that considered advanced constructions are the constructions from section 3 in Hartshorne and the constructions from section 10 in Hartshorne. So these would be things where you're dealing with area along the way, or a couple of the a little bit more complicated ones where we're looking at Euclid's Book 4 with inscribing and circumscribing things. Okay. And here are some examples of those guys. Now, one of the things that I would definitely recommend making sure you're comfortable with what I'm expecting formatting-wise with formal, proper constructions. You'll need to list out all the steps. You need to make sure you draw with a straight edge and compass your picture. However, if you want extra examples, especially since on some of these guys I was a little bit vague here, you may see things that are not explicitly listed out on this list. If you want to get some of those extra examples, almost anything I could possibly give you is inside of that website, Euclidia. That's that app, that game that I recommended you guys going in and checking out at the beginning of this semester. And it'll give you constructions that are far more advanced than what I would give you. So if you can get high enough level in that Euclidia game, you'll definitely be fully prepared with anything I could possibly give you with respect to the construction questions. Note, you do have to get far enough to get to all of those, though. Okay, but that would be an extra resource if you want to use it. Note the upsides of Euclidia, it won't let you do a step that's not a true construction step. Downsides of Euclidia is it's all online, so you're not actually getting practice using your straight edge and compass or writing out all of the steps as you go along. And the last page. So the last page gives you some idea in terms of proofreading questions. So with respect to proofreading questions, I will not give you any super advanced, super complicated proofs. Okay? How I pick these proofs is I assume or try to get a proof that could be completed within 15 minutes. It's actually the same way that I grab the construction questions as well. Okay? Now, if you have an on-paper test, this would be a situation where at the top of the page I would give you what the statement is to prove. If there's any picture associated, I would typically give you what the picture is. And then you have your blank piece of paper. You draw in your T-chart. You list the steps you want. You list the reasons you want. Okay. In an online version of this, you could see it in one of two ways. One is where you see an actual T-chart and each one of the steps has a text box that you type in what it is you need to type in at each step. Or it might be what's called in Canvas an essay question where you literally would just type in everything. If you get a total free response essay question, which you might, you can use the button in the menu that says a chart and it'll actually sort of replicate a T-chart scenario where it will actually give you what looks like a table. And then on one side of the table, so if you in your first column you can write in your statements, and on your second column you can write in your reasons. Okay. And then you can also use your math mode button that looks like the square root X symbol and fill in the correct symbols. Now, back to content. In terms of proof questions here, I am not going to give you terribly complicated. They will either be really, really, really straightforward, or they will be slightly more complicated than straightforward. Okay, so what I've done for you is I've put together a couple of samples, and these are some of the samples. If you can correctly get through or navigate all of these examples, while you're likely not going to see these specific examples on the test, you'll be able to get through whatever you do see. Namely, they have the same techniques. So the first one here is proposition 1. This was the proof of the construction of an equilateral triangle. Try to do it on your own. It's relatively short, but you also have the full solution in our notes because we did it together in class. Okay. Now, this next one was proposition 5 from Euclid's book 1. We've done this together in class. And this one talks about showing that the base angles of an isosceles triangle are congruent to each other. It was a two-parter when we did it in class. If I gave this to you on the test, and I've done this in previous semesters, I would only ask you to prove that the base angles of the isosceles triangle are congruent, not the extra add-on that we actually did in class. Notice this one is not as straightforward as the equilateral triangle. It has, roughly speaking, 3 main components that you'd need to navigate. Another example here is proposition 9, which looks at the construction when you bisected an angle. Another example is proposition 10. This looks at the proof of the construction of bisecting a line segment. We did the proof of bisecting an angle in class, and I believe we outlined the proof of bisecting a line segment in class. Proposition 31 was the construction of a parallel line. Depending how the construction of a parallel line goes, this is an extraordinarily almost no-step proof. The way we did it in class, there was like one main statement and a couple of statements that tell you what the actual construction was, would be all that it would entail. If you do it a different way, if you do the construction a different way than what we did in class, you'd have like 2 extra steps. So still straightforward, but a little bit, several versions depending how the construction went. Okay. Note, let me make sure I grabbed them all. I believe all of these guys are constructions. If you are given a construction question to prove, I will likely give you what the construction is at the top, then have like a line and then say, all right, now prove that that particular construction actually is valid. Okay. So you wouldn't have to worry about which version of the construction you're dealing with. Now, proposition 35, this one we did recently in class. This is the one where you had your 2 parallelograms and they shared a base and we claimed that they had the exact same area. Proposition 17 from book 3, we did the construction of this particular proposition in class, but we didn't talk about the proof, so this would be a new thing to look at. Now, I did post some extra notes on Canvas that actually goes over the outline of what this proof would be, and it's highly related to your exercise, or it can be related to your exercise 1.10 that you guys had recently from homework. Now, from your book, exercise 1.5 talks about diagonals of a rectangle, specifically that the diagonals of a rectangle will bisect each other at so they're the same length, and when they cross each other, that intersection point actually bisects both of these 2 angles. We didn't actually have exercise 1.5 as a homework set assigned. Instead, this semester, I switched it out with a proof question from the Configure It site that's very, very similar to this. Now, in class, we talked about the proof of right angle side side. This can be found in your textbook as lemma 3.2 or exercise 1.7, but it's also, we did the full proof in class as well. Okay. And then there is exercise 1.8, which is also a new one, although we've talked about it with respect to constructions and one of your homework questions previously. This one says, hey, if you take a triangle and you bisect all of the angles of the triangle, they will meet in exactly 1 point. And a step further that we actually did in homework in our previous discussions was, hey, that intersection point is actually the center of a circle that circumscribes the triangle. This particular exercise or this particular question, if you got something similar to it, would just be asking you about the triangle. So it would look like something like this. It says if you bisect each of these sides. So those guys are the same, those guys are the same, those guys are the same. Why is that center actually at 1 point? Why did the third angle bisector not miss the point? The previous intersection point. If you are looking for extra examples in terms of types of proofs that you might see, a great resource that will also tell you if you're on the right track is going back to our Configure It site. We're at the tail end of where you'll see homework assignments assigned out of Configure It, but I did attach to our class in that Configure It site something like 20 to 30 problems, and I on purpose chose ones not just that would turn into homework questions, but also ones that relate specifically to the things that and topics that we're covering in our class, as well as looking ahead to potential proof questions that you could see on test 1. Now, one of the things to watch out for on the Configure It site, this site does not use exactly the same notation that we do in class, and that's specifically on the names they give to the things that they're citing. Things like side angle side, totally the same, but they'll sometimes in their descriptions do a little bit longer description, which is totally and completely fine. But in terms of our test, I will expect you to cite things based off of Euclid. Okay, so that would be the only downfall in terms of using the Configure It site. But that gives you a full crash course of the different types of things, both how the question, formatting of the types of questions and formats and symbols that you need to worry about, as well as content topics that you need to worry about with respect to test 1. Okay? And in class, we will go over more specifics in any questions you guys have. Well, when I say more specifics, I don't really mean more specifics based off of what I give here, but more specifics in terms of if you guys have specific questions.